There are places in the world where innovation doesn't just move fast, it moves in silence. Hidden behind layers of security, far from public view, entire industries are being reshaped without announcement, without permission, and without competition. In China's vast coastal shipyards, something unusual is happening. Not just ships are being built, but components so advanced, so rare, that the rest of the world can't replicate them. For decades, global shipbuilding was a shared space. Europe engineered precision. Japan mastered efficiency. South Korea dominated scale. But now, a shift has taken place. Quiet, calculated, and undeniable. China is no longer just building ships. It is designing the future of what ships can be. At the center of this transformation are parts. Small, often overlooked, but critically important. These are not standard engines or basic hull structures. These are specialized systems, precision-built components, and proprietary technologies that exist nowhere else. And here's the unsettling reality. Many of these parts are not available for export. They are restricted, controlled, and in some cases, completely hidden. The question is no longer whether China is advancing, it's how far ahead it already is. And more importantly, why the rest of the world is being left behind. China's rise didn't happen overnight. It was engineered, layer by layer, industry by industry. What began as a manufacturing hub for low-cost goods evolved into something far more powerful, a nation capable of producing at scale, with precision, and increasingly, with innovation. Shipbuilding became one of its most strategic sectors. With access to raw materials, a massive workforce, and state-backed investment, China rapidly closed the gap with global leaders. But catching up was never the end goal. Surpassing them was. Today, Chinese shipyards don't just assemble vessels. They integrate complex systems designed in-house. Components that once came from Europe or Japan are now being replaced by domestic alternatives. And not just replaced, improved. This shift has created a new kind of dependency. Shipping companies around the world, once reliant on diverse suppliers, are now turning to China for critical parts. Not because they want to, but because they have no alternative. And as this dependence grows, so does China's control over what gets produced, what gets sold, and what remains out of reach. What exactly makes a ship part forbidden? It's not just about rarity, it's about capability. These are components designed to push the limits of performance, efficiency, and endurance. Some improve fuel efficiency beyond current global standards. Others enhance stealth, reducing a vessel's detectability across multiple systems. Take propulsion systems, for example. Advanced designs now being developed in China are rumored to significantly reduce vibration and noise, critical for both commercial and military applications. Then there are specialized alloys, engineered to withstand extreme pressures and corrosive environments, extending a ship's lifespan far beyond traditional limits. But perhaps the most intriguing are the integrated digital systems. AI-assisted navigation, predictive maintenance modules, and real-time optimization software embedded directly into the ship's core functions. These systems don't just support the vessel, they think for it. And yet, access to these technologies is tightly controlled. Export restrictions, proprietary protections, and strategic limitations ensure that only select entities ever get close. To the outside world, these parts are more than advanced. They are inaccessible. And that inaccessibility is exactly what makes them powerful. Modern trade depends on movement, and movement depends on ships. From oil and gas to food and electronics, nearly everything that powers the global economy travels across oceans. But behind every ship is a network of parts, thousands of components working together to keep it operational. When even one fails, the consequences ripple across supply chains, industries, and entire economies. This is where China's role becomes critical. As more shipbuilders and operators rely on Chinese-made components, the global maritime industry becomes increasingly tied to a single source. It's not just about cost, it's about availability. In many cases, the parts produced in China simply cannot be sourced elsewhere. And when those parts are restricted, delayed, or withheld, the impact is immediate. Ports slow down, deliveries are missed, costs rise. What was once a diversified system is now consolidating. And with that consolidation comes vulnerability. The gap isn't just economic, it's technological. While other nations continue to innovate, the pace is uneven. Replicating advanced ship components requires more than blueprints. It demands materials, expertise, and years of development. China has invested heavily in all three. Research institutions, industrial partnerships, and government-backed programs have created an ecosystem where innovation thrives. Meanwhile, competitors face fragmented supply chains, higher costs, and slower development cycles. The result is a widening divide, not just in what can be built, but in what can even be imagined. And as that divide grows, so does the realization that catching up may no longer be enough. Control is not just about production, it's about containment. The most advanced technologies are not simply manufactured. They're protected, compartmentalized, and strategically concealed. Within facilities like these, information does not flow freely. It is segmented. Engineers often work on isolated subsystems, never seeing the full architecture of what they are helping to build. This structure isn't accidental. It reduces risk, prevents leaks, and ensures that even if fragments of knowledge escape, they remain incomplete, impossible to replicate without the whole system. In this environment, innovation becomes both a weapon and a guarded asset. China's approach to industrial secrecy blends state oversight with corporate discipline. Access is tiered, data is encrypted, even internal communication is monitored. The result is an ecosystem where technological breakthroughs can develop in silence, shielded from external scrutiny and internal exposure alike. For global competitors, this creates a blind spot. Without visibility into the full process, materials, design logic, integration methods, reverse engineering becomes guesswork. And guesswork in high-precision engineering leads to failure. So the question isn't just what China is building, but how much of it the world will never fully understand. In maritime strategy, marginal gains create exponential advantages. A slight reduction in fuel consumption extends range. A minor improvement in noise suppression enhances stealth. A faster data processing system shortens reaction time. Individually, these upgrades seem incremental, but together they redefine capability. China's exclusive ship components are designed with this philosophy in mind. Integrated propulsion systems reduce drag and vibration, allowing vessels to move faster while consuming less energy. Smart hull materials adapt to pressure and temperature changes, improving durability in extreme environments. But the real transformation lies in system integration. These ships are no longer collections of independent parts. They're unified platforms. Sensors, engines, navigation, and AI-driven analytics communicate in real time, optimizing performance continuously without human delay. For commercial fleets, this means fewer breakdowns, lower maintenance costs, and higher operational efficiency. For naval applications, it means unpredictability, ships that are harder to detect, harder to track, and faster to respond. And when these capabilities are built on components that others cannot access, the advantage compounds. It's no longer just about having better ships. It's about operating on a different technological level altogether. The global response is underway, but it is fragmented and reactive. As awareness of this technological shift grows, nations are attempting to rebuild capabilities that have quietly eroded over time. Investments are announced, policies are drafted, alliances are reconsidered, but rebuilding an industrial ecosystem is not immediate. It requires supply chains, skilled labor, research institutions, and years of coordinated effort. Meanwhile, China continues to scale, expanding production, refining processes, and accelerating innovation cycles. What makes this situation more complex is the depth of integration already in place. Many global shipping operations rely on Chinese components, Chinese manufacturing, and Chinese logistics networks. Replacing that infrastructure is not just expensive, it's disruptive. So the response becomes a balancing act. Reduce dependence without destabilizing existing systems. Diversify supply without sacrificing efficiency. Innovate quickly enough to close the gap, but carefully enough to avoid costly missteps. From within China, this reaction is observed, analyzed, and anticipated. Every policy shift, every investment, every attempt to compete feeds back into a system that is already moving ahead. And while the world debates its next move, the gap continues to widen, quietly, steadily, and without pause. The global response is underway, but it is fragmented and reactive. As awareness of this technological shift grows, nations are attempting to rebuild capabilities that have quietly eroded over time. Investments are announced, policies are drafted, alliances are reconsidered, but rebuilding an industrial ecosystem is not immediate. It requires supply chains, skilled labor, research institutions, and years of coordinated effort. Meanwhile, China continues to scale, expanding production, refining processes, and accelerating innovation cycles. What makes this situation more complex is the depth of integration already in place. Many global shipping operations rely on Chinese components, Chinese manufacturing, and Chinese logistics networks. Replacing that infrastructure is not just expensive, it's disruptive. So the response becomes a balancing act. Reduce dependence without destabilizing existing systems. Diversify supply without sacrificing efficiency. Innovate quickly enough to close the gap, but carefully enough to avoid costly missteps. From within China, this reaction is observed, analyzed, and anticipated. Every policy shift, every investment, every attempt to compete feeds back into a system that is already moving ahead. And while the world debates its next move, the gap continues to widen, quietly, steadily, and without pause. The next phase of shipbuilding will not be defined by steel alone, but by intelligence. Vessels are evolving into autonomous systems, capable of making decisions in real time. Navigation routes are optimized by algorithms. Maintenance issues are predicted before they occur. Entire fleets can be coordinated remotely with minimal human intervention. China is positioning itself at the center of this transformation. By controlling both the physical components and the digital architecture that powers them, it is shaping a future where ships are not just tools of transport, but platforms of computation. Imagine vessels that adjust their structure mid-voyage to reduce drag. Systems that reroute automatically to avoid geopolitical risk zones. Engines that recalibrate themselves based on fuel quality and environmental conditions. These are not distant concepts. They are emerging realities. And at the core of these innovations are the same restricted components: advanced sensors, adaptive materials, integrated AI modules that remain largely inaccessible to the outside world. Whoever controls these building blocks would define the rules of the next maritime era. Not just how ships are built, but how global trade itself is conducted. Every shift in industrial power reshapes the global balance, and maritime technology has always been at the center of that transformation. From the age of sail to the era of steam, from steel hulls to nuclear propulsion, each leap has redefined who leads and who follows. What is unfolding now may be another such moment, but this time, the shift is quieter, less visible, yet potentially more consequential. It is happening not in the ships themselves, but in the components that make them function. The hidden systems, the unseen technologies, the parts that determine performance, efficiency, and control. China's dominance in this space raises difficult questions, not just about competition, but about access. If critical technologies remain concentrated, what happens to industries that depend on them? If innovation becomes centralized, how does the rest of the world adapt? As that ship disappears into the darkness, it carries more than cargo. It carries a signal, a glimpse into a future where technological leadership is no longer shared, but held. And the question that remains is not whether the world will respond, but whether it can respond fast enough to matter. If you found this eye-opening, subscribe for more deep dives into hidden technologies shaping the future.